Okay, so I just started it. Yeah, the record is started. So yeah, everyone, I welcome you. I am extending a warm welcome to everyone for joining this webinar today. Uh, for us today, the water treatment will be discussed, or rather the more information, first-hand information will be given us today by Mr. Lim Kai Keng, who is an engineer by practice or by train. He is a trained engineer, chemical engineer actually, and from the Eco Solution Service, and Mr. Raymond, who is the director of Oasis Chemical. Mr. Lim is joining us from Johor in West Malaysia, and Mr. Raymond is from here in Sarawak, Kuching. Both of them have almost 15 years or more than 15 years experience, so we can expect some very informative or very useful information from both of them from the perspective of hands-on experience. So I don't need to mention how water is important. We can talk a lot, we can study, we can read, we can listen, but those who are suffering from the water shortage from part of the world, they know the value most. So I think another thing is water, the fresh water, in fact, is not increasing. The portion of part of the fresh water is not increasing. It is reducing day by day. So it is extremely important to reserve and rather to purify the water or make the wastewater that we use every day to make it usable, reusable every day. So I don't want to take further your time. I would like to pass my floor to Mr. Lim to share his experience to us. So Mr. Lim, the floor is yours.
Yeah, good afternoon. Thank you for inviting me for this session. I think I will start to share my presentation slide. So can you all see?
Yes.
Today my topic is actually regarding smart water management toward Industrial 4.0. And since my area, we cover most of the textile industry. So today we're going to talk about some application and how are we going to manage water at this textile industry. Right. So I think before I start today, the purpose of the presentation is actually to make sure the water having a consistent water quality for this textile industry. So the process we are using is what we call advanced water management treatment system, which is basically it consists of RO system. And when we talk about smart water management, today we are going to introduce some cloud-based monitoring system. So it's actually an Internet of Things, and it's a system how we're going to manage our system. And for the payback of this presentation is actually we will be able to help industry to reduce the defect because of the consistent water quality improvement and reduce the industrial shutdown because of it reduce the amount of water inconsistent quality and hence reduce the pollution. So let me introduce areas known as Batu Pahat. Is actually a town situated in Johor. So this is a town whereby it was known as textile town. I think a lot of you all may be wearing Nike and other brand like this Uniqlo. So if you turn back to the clothing and you will realize it's written there made in Malaysia. So most of the time, this clothes will be manufactured in Batu Pahat area, Johor, Malaysia. So, but at Batu Pahat, we are facing a lot of problem or a lot of issue because of annually there's a lot of utility cost increase. Every year we are talking about the government supply water is getting more and more expensive. And when you talk about modern manufacturing process, in fact, you need higher and higher quality of water requirement. One of the example is you need better, higher boiler operating pressure. Because when you have higher boiler pressure, you actually need much purer water as the feed water. So for the dyeing process is you do not or you cannot have high suspended solid, high hardness and this sort of thing. It will actually disturb the dyeing process. So what is the problem actually we are facing over Batu Pahat area is every year the rain or extreme weather is getting more and more severe. So later I have a rain profile throughout this area, and you can see what's actually happened. So when you have a dry season or drought season, you will realize that there's a lot of there's an effect known as seawater contamination. The seawater actually go inland. And let me show you, this is the map of Johor. Okay, so where is Batu Pahat? This is Batu Pahat area. Okay, so this is the 10-year waterfall at Klang area. Because if you look at back, okay, Klang area is here. So the water source actually will flow from Klang area down to Batu Pahat area and go to sea. That's why it is very crucial to understand how the rainwater flow. Okay, so by the way, if you all have anything want me to stop and clarify something, please do so. So let's see what's going on here. Okay, 10-year rainfall at Klang area. You can see actually February will be the drier month throughout 12 months. So let's see at this 2002, the lowest rainfall will be about 29 millimeter. But if you look at it over this 2011, it's getting lower. And the worst will be at 2014. You can see almost there's no rainfall. The whole month there's no rainfall. So meaning that the weather condition is not actually favoring for those industry. It depends on using river water to process. So this is the town of Batu Pahat. So anyone know what is the total dissolved solid for sea water? Anyone? So I think I explained myself. You don't know, huh? Okay. So this is the, you look at the star. This star is the industrial area of Batu Pahat. It's about 26 kilometers away from sea. Okay. So, okay, so now I give you the answer, which is above 25,000 ppm. So inland, when there's no rainfall from upstream, so the seawater contamination actually go inland. So we are getting about 10,000 ppm, the highest. So it's about half of the seawater salinity. So it's very salty. So this water is actually not advisable to use at human consumption nor industrial application. So this is the part whereby we want to talk about how are we going to manage our water. So the water challenge is a seasonal effect. So after some study, we realized that we have 9 months whereby we have normal water TDS. And we have 2 months of dry season, and we have 1 month which is drought season. This is the time whereby seawater contamination will actually occur at Batu Pahat area. Okay, the outcome is the industry will be facing severe losses because they can't do their product. There's a lot they do because the dyeing process cannot proceed. And you all may know textile industry, for normal factory, they consume about 2,000 to 3,000 meter cube of water per day. So that is for one factory. The largest textile industry at Batu Pahat area consume about 1,000 meter cube of water per hour, which is 24,000 meter cube of water per day. Okay. So, am I talking too fast, or shall I slow it down a bit?
No, it's
So
reasonable.
anyway,
you just go on.
I think
It's reasonable.
it's okay.
Just because I did not hear any feedback, so you just talk feedback me a little bit. So okay, so just now is the problem we are facing over industrial area. So the solution that we are going to propose is actually is a wastewater recycling system, and we are using ultrafiltration plus reverse osmosis. So using any hardware, it will not, how to say, it must come with a software. So this is the part whereby we introduce our smart water management, which is a cloud-based system. It's a real-time monitoring system, and it was added some prediction feature, whereby we are using the history record to actually predict what is going to happen, and so on, what is the action that we are going to take. Okay, so since there's a number of water sources, let us look at the wastewater as the first step of what we are going to do. So to process the wastewater, we will mix with this okay, the ultrafiltration plus wastewater reverse osmosis. So is we are doing this recycling processor to process further for this wastewater. So here, I think you can't a bit hard to understand. Let me explain with some picture. So for wastewater treatment, so any textile wastewater, because it's a dyeing process, it's actually quite dark and is come with some color. So you all know that Malaysia, we have two types of standard. We have standard B and we have standard A. So for process or the factory inlet, we are actually require higher than standard A. So certain process need to be taken. For example, you need external or filtration, UF system plus RO system to be able to let us apply at this boiler feed water. So you can, this picture, you can see that if you actually enhance the process, only you can achieve what we call the advanced water management, whereby we're able to recycle the water. So wastewater recycling is good, but it is not realistic in or what we call is not economically advisable, because it's the most expensive process. So what happened is, for industry, is expensive. So their first choice will be using river water as their first choice. Relatively, treatment for this river water source will only cost you about 10 to 30 cents for these two sources. Whereas for wastewater, we are looking at about 2 to 3 ringgit. For the government water, the SAJ is actually referring to government water. So at Johor is 3 ringgit and 30 cents per meter cube. So this one is about 20 cents. So, so if you look at it, because of the economy reason, okay, this two sources will be our major water resources because of the price of the water. No one will just go to do wastewater recycling if it's not economically viable. So, but if you have this dry season and drought season whereby you have seawater contamination, so you have no source of water but to use wastewater to recycle. Okay. So this is how it looks. So if you look at it, this is the location of the factory. Okay, the factory is, just now we mentioned about the factory is located 26 kilometers away from the sea. So let us look at the picture. But if you look at it, is the river side. This is the palm house from the river. It's about 5 kilometers away to the factory. So at factory, their water treatment distance is about 200 meters away from the factory to doing the process. So to, to, to have a system to maintain which water source and which one you need it, the best way we'll propose is using this wireless cloud-based to monitor. This is whereby you need the internet to come into picture. So what we do is, because it's 5 kilometers away, so if you want someone to monitor the system, you need to travel up down 5 kilometers to actually measure and tell you when is this high TDS of water, or what we call contaminated seawater coming inland. So it's very difficult because of the distance. So what you can do is we actually propose to put in a wireless system and sending all this data into cloud. And using this cloud, it will collect and it will predict what sort of action we need to do. Shall we activate our RO system? Shall we recycle our wastewater to manage our water resources? Okay, so smart control, a real-time data collection. So in this system, later we will go into one of the demo, cloud-based monitoring dashboard to actually show you how it look like and how this system will tell the operator what is the scenario of the water look like. Basically, we identify the season by giving them a name as normal water, dry season, and drought season, and what sort of action we need to take if this type of scenario come, and shall we running this wastewater treatment system into the advanced water treatment to make sure we produce our water for our process. So this is how the process flow look like. So when we have normal water, we are at normal season, okay? And the TDS of the water, just now we mentioned about when you have seawater is about 25,000 and above ppm. So this one is river water source 1 and 2. So the TDS is only 100 ppm. 100 ppm of this mineral, or what we call TDS, is actually known as total dissolved solid. So we will use 100% from river water and go to our production. And it also can be used at our boiler as our boiler feed water. None of the wastewater need to use for our as a selection of our water source into our production, because it's more expensive. So no one will actually waste more money just to produce the water for the production. We'll use as the cheapest source. But the situation change when you have this dry season come. Dry season come, our water sources will have higher TDS. Just now we mentioned the TDS is about 100 ppm. Now it went up to 500 to 1000 ppm. So this is the time whereby we need to run part of our RO system to further purify, to reduce this, to reduce the amount of TDS going to our production. So you can see the amount of salt reject coming out from our advanced water treatment is getting higher. And the amount of water just now is 100% increased to 130%. This is due to when you have an RO system and your input TDS is higher, you need to reject more brine, or what we call a reject water, so that we can get purer water out to production. So for normally RO system, we can have this 99% of reject of this salt. If we have about 1000 coming in to our production, we can get about 10 ppm into our production. If we purely refer to TDS as our indicator. This is for dry season. Let us look at drought season. Drought season is whereby one of the water source is totally dry up. We have no, one of the water source is dry up, so we have no more water. Whereas for our river water, we have seawater contamination coming in. So this is the time whereby we need to activate our wastewater as one of the feed water into our advanced water treatment system. If you look at it, we need to mix water 50% of the river water plus 100% of our wastewater into the advanced water treatment system, and about 50% of the concentrate, or what we call the concentrate of TDS, reject as brine to throw away, whereas the purified water from advanced water treatment system to go to production. So this is a time whereby the operation cost of the water treatment at the higher peak, but we still manage to produce water. So there's another scenario that the river water TDS went even higher, and one of the water sources dry up. So what happened is you need to start to use government water come into picture. So we use government water mixed with wastewater, go into our advanced water treatment system, and we let 50% of the brine water to throw away, high concentrate, and it produced 100% of this low TDS water for our production. This is another scenario when you have drought season. So up to now, anyone have any question?
For fun, no. We will ask later during the Q&A session.
I have to stop a while for some drinks.
Yeah.
Okay. I'm not used to giving speech, so anything you all just let them know. Okay.
Okay, so, sure. Students, if you have any question, please ask us.
Okay. So what happened is just now we mentioned about we have this cloud-based monitoring and that sort of thing, but you need to have some smart sensor to actually sending some signal or data back to the system. So at wastewater plant, we will actually install this COD analyzer to analyze COD, and we'll put in conductivity or TDS meter, pH, DO to actually monitor. And this one is the at raw water system. This is the treatment system for liver water. So we'll put in this pH, hardness. This one is hardness, conductivity, pH, and a lot more like this pH as well to actually control. This one is clarifier, sand filter softener, Then, okay, this is the part whereby we have our RO system. RO system, we have more monitoring devices like turbidity, flow meter, conductivity, and another flow meter. So actually you can control at your boiler as well. So if you have high TDS, somehow the advanced water treatment system is not good enough. You need something to tell you whether any high TDS went into our boiler. So you can put in all this. So I think we've been talking a while about this feature. Let's look at, go into the actual dashboard of our cloud-based monitoring. Okay. Okay, so for student, when we talk about Industrial 4.0, we know that we have 6 criteria to actually qualify a certain process known as Industrial 4.0. I think it's 8 of them. So we do not have 8 of them, but we have 6 of them. First thing is the internet security, big data, Internet of Things. So just now we mentioned about the location whereby we put in all our instrumentation. Okay, look at it. The water, okay, not very good at computer. So if you look at it, this point, this red point, this pin is actually the, oh no, where am I? Okay, just this one, the yellow one is our pump house. Okay, our pump house here. Our factory is actually pink color. The green color one is actually our wastewater treatment system. So just now I mentioned the distance from factory to liver is about 5 kilometers. Okay, so this is the place whereby we need to have this smart water management, and all the data will be collected at this dashboard. Okay, what this dashboard tell you is, first thing it will tell you about the pH. You look at water source 1. There's no data indicating this water source is already dry out. There's no water. So water source number 2, it will tell you the pH, conductivity, flow rate that we are recommended to pump into our advanced water treatment system. And we have our wastewater. At this moment, at this date, you do not need to pump water into our advanced water treatment yet, because you can use 100% liver source number 2. So And what is the TDS you are going to produce at your RO per minute? This is the flow rate you are getting. So let us see about the big data. The big data is actually, let me zoom in a bit. Let me zoom in. Okay, so we have this. Okay, so I selected January, 8th of January. This is the time whereby it will tell you, you look at it, it will tell you this cloud-based computing is, it will tell you that at this moment, this date it is under normal scenario, whereby most of the water source is running at normal season. So you look at it is our liver water source, number one. Okay, number one, the TDS is very low, it's about 46 ppm. The pH is also reasonable. So we'll use 100% of liver source number one as our feed into our production. So whereas number one will be at this blue color. Look at it. This one is blue color. So we'll use blue color into our production. So this is what happened. So let us select another date. Okay, this is the time whereby you can see the dry season start to come. Just now you remember we show you the rainfall for Kluang area. So February is the driest season in Johor area, driest season. So now is approaching February. You can see is indicating dry season. And our water source number one is actually dry up. There's no more data here. So if you look at liver source number two, okay, can see the pH is 4. This is quite usual at Batu Pahat area. The lowest we detected is about 2 because of what we call pollution, agriculture, and a lot more of this pollution problem. So that's why we say pollution is getting more and more serious. So the TDS start to rise up to 800. And since we do not have liver source number one, we will use 100% of liver source number two as our source into production. Okay, so some people may ask me, is there any programming that you write to actually predict what is the water source? We have some data here. Let me show you. Okay, this is a very brief selection of water, how the programming actually run to actually select the water source out. This is what we call some, what's the name? I can't really know what's the proper name. So actually the feed water source, it will tell you if it's true, then it will select the lowest TDS. You can see, select the lowest TDS. Then if you have restart or source number one and your liver source number two, if this one is lower, it will select. If let's say you have none of them, then it will go to our wastewater. And when you go to our wastewater, just now you look at the picture of textile industry, the water treatment, standard B is the discharge standard. But for us to recycle the wastewater, we must make sure the wastewater comply to standard A. Otherwise, this wastewater will give problem to our RO system. So if it cannot comply to standard A, we will go for another process to hire the decoloring agent or a type of chemical to actually remove more dyes up from the water. So and it come out from this wastewater treatment system. And if the TDS is higher than 2000 something, and it will start to mix with the SAJ, or what we call the government water. Let me see, water actually disable, and it will slowly produce the TDS that we want, and it start to go into our RO system, and our RO system will start to measure a lot of data. I mean, this is the detail of how the water treatment is actually run, because you need to know the pH, you need to know the turbidity. As just now what I mentioned, we have this, we have few system, we need to have a lot of feedback from it. Only then we will have our RO system to run at optimum. Okay. So this is how the programming look like. Where are we just now? Okay, let's go back into our dashboard. Okay, so this dashboard is actually telling us about this water. You can log out, and let's see. Okay, let's go to drought season. Okay. Now you see, I selected a date whereby there's been a very long while there's no rain, so we'll identify at this as the scenario of drought season, and you can see all the data is changing. The software is actually predicting what is the action that we need to do. So you look at it is the lever source number 2 is actually the TDS for source number 2 is 2000 something, and we realize that our wastewater TDS is actually lower. So we will select wastewater as 100% fit into our RO system. Okay, so this is what happened, and let's select another date. Okay, so if you have a look on it, this is the time whereby it start to rain. It's back to normal. The water treatment start to go to normal procedure. So I doesn't know whether I presented this presentation in such a way you all can catch what I'm saying, because it involves quite a number of water sources, and it involves some programming, and it actually involves what we call the internet cloud-based monitoring and this sort of thing. And let's see another function of it. This one is the daily, and let's go to TDS record. So as mentioned, big data, we need to have a lot of data. So here is what happened is it record most of the TDS over the thing, over this cloud base. So it will tell you each water source, what is the TDS, and you can select all the date whereby you can see, I think there's one, if you get lever source, number 1 is 0, meaning that the water, there's no more water at this water source, so that's why it's indicating 0. So this is the time whereby you have high salt water. The seawater contamination is actually go into our liver. Okay, so whereas government water, because SAJ is actually referring to government water. You look at it, government water, there's not much changes. The reason is government water at Batu Pahat, they are taking even higher, they are taking another source of water, which is even further away from Batu Pahat. That's why there's not much changes in this government water TDS. Okay. So for this, you look at it, this is the overview of our map. You can see where are we. Okay. Right, I think that's about one chapter for this Industrial 4.0 and how we actually manage our water resources. So I think I will stop here for this water management, and later on we continue with another topic, which is how we actually design and select wastewater treatment process. So I think I will stop the presentation on this advanced water management. I doesn't know whether is there any question?
Excuse me. Hello.
Yeah, yeah.
Yep. Go ahead.
I'd like to ask one thing. So,
Mm.
for your advanced water treatment system, I want to ask why is it that the ratio between the brine solution and the purified solution is like 50 to 100?
The detail, okay, you look at it, is this is the RO system here. So RO system, we are having membrane, okay? So there is certain parameter we need to control for the brine, or what we call a reject, okay? So the feed water, I'm putting 100% of inlet. Now, what should I say is this one, the outlet is 100%. Because of high TDS, you actually can't run at normal situation. Normal situation, our reject, some people is controlling at 30%, meaning that the feed is about 130%. Why 30 and why sometimes it's 50? This is due to there is a chemistry known as the limiting factor. I take one example. The limiting factor for silica is 150 ppm. Okay, so if let's say the reject for this silica is 150 ppm, and your feed water is already having 30 to 80 ppm, meaning that you only can concentrate the water about one time. So you need to have a higher reject. Actually, water treatment, what we're putting here is a simplified version of how we operate that. So when you actually operate it, you have to consider the limiting factor like silica, some other factor like hardness, or what we call calcium plus magnesium. So every parameter every chemistry have their limiting factor. So here we are talking about silica. So if it's high, then you have 50%. Am I answering your question?
Yes. Okay. Thank you.
Okay. So I think I have a lot of Q&A for students to ask. So just ask, I will answer most of the question if I can.
Okay, hello. Sorry, my mic was mute. So, anyone has any other question? You can just ask directly if you want, or you can type. And by the time students are typing, I have one thing to know from you actually. Yes, thank you very much. It's quite interesting actually. So your this system is intelligently programmed to choose from different sources, right? It depends on the availability of the water, or depends on the availability or suitability of the water contamination or water property. What is the most highest priority do you give for this? That the prior, I mean, if let's say ideal, I mean, yeah. So go ahead.
Yep, I think it's just now. I think it doesn't make it so clear lah. Because firstly is we need to understand the cost for each water treatment, each source of the water sources lah. Just now I mentioned about liver water. If you process the water, it will cost you about 20 cents, less than a ringgit. So just now I also talked a little bit about wastewater treatment. It will cost you about 2 ringgit. So and another one will be SAJ water. Let me put it here. SAJ water. SAJ water is what we call the government water lah. Syarikat Air Johor, or what we call the government water. The government water costs us about 3 ringgit. Costs us 3 ringgit and 30 cents. Okay, so the wastewater here we are talking about 2 ringgit per meter cube, per meter cube. Whereas for liver water source, the treatment cost is only 20 cents. So if you look at it, the gap between each water source is very big. Each water source, the treatment cost for water source is very big. So it's very obvious for economic reason, people will select liver water as your priority. But as I mentioned, because of this dry season and this drought season, one of the water source, it will deplete. And the other source, because of dry season, you have inland water contamination. So people may ask, why don't we just use desalination? Desalination is even more expensive compared to wastewater and RO system. So it's not really an option to go for. So we are not talking about desalination of the seawater, because that process is even more expensive. And this is actually the economy for running our water treatment at any water treatment plant. So next will be, we will consider the cost for each source. Secondly will be chemistry. Because if you having this seawater contamination, very high DDS. Just now mentioned, sometimes it can go to 10,000 ppm. And I checked this drinking water standard for human consumption. The permissible limit is about 500 ppm. So this water is not suitable for drinking. So the selection of water will be first economically, secondly will be on this chemistry. Then it will be how the difficulty to operate the system. And that's the reason why at the end we develop such a system to select which source we're going to use and how are we going to manage it, because you have distance from pump house to your factory. There's you wasted a lot of energy how to monitor. That's why at the end we develop such a software to monitor our water resources. Am I answering the question?
Yeah. It's pretty much actually.
Ah,
So just to clarify one thing that your system is highly depending on the computer programming, or you really do some wet testing, like I mean, chemical testing on site as well.
the chemical testing is actually done by this instrumentation because let's see, yeah. Okay, so we install quite a number of instrumentation
I see.
at the wastewater treatment. You see, you have conductivity, you have pH, you have DO, you have COD.
Mm-hmm.
The idea of COD is actually, just now if you look at the flow chart, you will
Mm-hmm.
realize that we need to, when we have problem with the water resources, we need to push our wastewater from normal discharge standard B to standard A, and then we will be able to recycle the water, because our system cannot take standard B into the system. You will clog out and you will choke out our system. So you have to take certain action
I
to
see. So that
actually
I.
make sure.
Mm-hmm.
So I think the orientation of the presentation is not very nice because I'm
No.
not
It's
used
very
to this.
informative. No, it's very
Ah,
informative. Thank you,
okay.
actually. And there is, yeah,
So
please.
the for raw water wise, we also install quite a number of it. Just now we mentioned about hardness,
Mm-hmm.
and hardness is whereby our RO cannot take high hardness. That's why we need softener. I think because of we want to talk about industrial 4.0, that's why I think we skip a lot of topic like what is sand filter, softener. I presume student will know.
Yeah.
So the softener is actually a ion exchange device which able to reduce hardness. Okay, the hardness. So without hardness, our RO can last longer, because RO is actually able to accept mono ion like this K plus, but you will choke out the RO membrane if you have bi ion 2 plus, aluminum 3 plus. This
Mm-hmm.
one is extremely dangerous to RO. So that's why just now we're talking about how much we're going to reject. Is actually depends on how much how to say, alien mineral going to our RO system. Then the amount of brine that we're going to reject away, we have to turn bigger. The how to say, we have to run bigger, turn bigger valve to have a higher discharge on this brine to discharge it away. I think
Okay,
I'm more
so
used to
yes,
people ask me questions.
yeah. So
Yeah.
talking about the process, actually, I would like to know about the boiler, because here you have the boiler. So what is the function of the boiler? And do you have cogeneration? I mean, you produce steam and then produce electricity in this plant?
Okay. So let me talk a little bit about why there's a boiler. Boiler is a device to have heat transfer into the process. When you are dyeing process, there's a few crucial parts. You want to make sure the dye sub is actually sticking into the fiber. That's why you need medium like water, and you need heat. Depend on each process, different material will have different temperature. So most of the time you need about 104 degrees Celsius in the dyeing machine. So we are sending heat, or this is what we call steam. Okay, the dyeing process, you need water, you need heat. So the steam actually will send this heat, amount of heat into the dyeing machine. So the dyeing machine will have sufficient heat so that the dye sub will go into our garment, so that we will produce this garment which have color. That's what we are wearing every day. So for this boiler, there's no cogen and that sort of thing. they are using very simple, what we call a water tube boiler to produce steam. So for textile industry, we are actually operating at 10 bar, and the steaming rate is 20 meter cube per hour. Okay, so because boiler is boiling the water, that's why heat efficiency and heat transfer is very crucial as boiler. A lot of water treatment plant consume a lot of energy because of the heat transfer starting to drop. When you have heat transfer starting to drop, you burn a lot more material into the boiler. So you wasted a lot of energy. In fact, if you have a RO water, it produces pure water into your boiler, then your boiler can run at higher efficiency, because when you boil certain water, it left behind the mineral in the boiler, say calcium. Okay, student, calcium, magnesium is good for building bone at our body, but it's not something good for boiler, because mineral left behind, then you will have scaling. Scaling will drop heat efficiency. If I'm not mistaken, 6 mm of calcium scale, or what we call a deposit, it will reduce heat transfer by 30%. This is whereby we wasted a lot of burning fuel because of improper water management. That's why I think when we are at second slide, we talk about we want to have good quality of water. That's one of the reasons why we need to have this. Am I answering the question?
Yeah, it's
Hello?
okay. It's okay. Yes, yes. Okay.
So there's no cogen here. Cogen, I think, is if you have gas, you are using gas turbine, then after you burn, it go to another section. Then is a cogeneration. This is not about cogeneration. We are purely at the section whereby we need pure water to generate steam at optimum efficiency. So if you're interested about boiler, maybe next time we can have a topic on boiler water treatment, because boiler is I think 70 to 80% of the energy consumption in textile or palm oil mill is actually used by boiler. If you have a wastage of 10–30% of energy because of improper boiler operation, this is the major wastage of energy, and it causes a lot of pollution. I think people will look at boiler as something always came out with a lot of black smoke and wondering why. A lot of time is because of improper operation. One of the example will be the boiler water treatment side of the boiler is failing. And that's the reason we are putting a lot of this sensor, for example, TDS, turbidity, and this thermometer to actually help the boiler running at optimum.
Yeah, I would love to have another detailed sharing session on boiler. I think everyone would love to learn more about it later on. We can have another. Thank you for this offer.
Hi, Mr. Ling. We have two questions in the chat room here from students. The first question is where to store the impurities after they get filtered?
Come again? Impurity?
Yeah, after they get filtered. after the
what filter?
I think should be like after filtering, then we have this
After you
waste or
separate
yeah,
the
yeah.
impurities. Yeah.
Okay.
So after you
I
purify the
think
water, then you have these impurities. Yeah. So this is a question.
okay. So the impurity here we are referring to brine is actually the concentrate of the salt. Okay, this is the TDS part. I think student may be referring to the sludge of the water, right? Let me see. Okay. Oh, where is the picture? Are you all referring to the activated sludge of the process? Or you're referring to impurity? Because impurity could be the sludge generated in the wastewater treatment, and impurity also could be referring to the amount of salt. Because salt, we can have this sodium salt, we have calcium salt, we may have some aluminium salt and this sort of thing. So I doesn't know whether you're referring to impurity in the sense that is the mineral salt or is the suspended solid type of impurity. If let's say is the mineral impurity, it was actually rejected at this RO system as prime, which is the concentrated salt. It come up here. That's why when you have higher concentration of water source, you need to discharge more brine away. You will have higher discharge of this water away. This one is actually throw away. You're throwing away the high brine away because it consists of salt. This is not actually considered as a scheduled waste or pollutant, but another source, another part. Let me see. Let me see. Another one on this. Okay. Another one when we talk about this wastewater aeration, and this one is diced up. This impurity need to be solidified and sell it to a Malaysia scheduled waste controller. And how are we going to collect all this sludge? I think later on we will go for wastewater system. I think I try to finish this smart water control. Then I think we have some topic about wastewater system and design. By the way, am I answering the question of impurity where it's go?
Yeah, student actually is asking about the salt.
Yeah,
Thank you.
says yes.
About salt.
Yeah.
Yep.
Another student, Ang, he is asking, he or she is asking that is the process of directing water from the different sources to different treatment system automated? I think yes, I was asking you of the question, and yes, it was automated, I think. I mean, the system understand, right? From when and where to take the water from.
Yep.
Yeah, so it's automated system. Okay, so yeah, anyone has any other question, students?
Actually, I'm wondering if you have any industrial problem in your plant, so we can initiate research collaboration. We can send you a final year research project student, and then we can work together to overcome the problem. So we will be very happy to work on that, because here we have a specialist in wastewater treatment. We have Dr. Bazlul and Dr. Loke here in our chemical engineering program. So what do you think? Yeah.
You are inviting me to involve in some of your project? Yes, definitely. You send me something if I have time.
What I said, if you have a project, I mean, in your plant, if you have any industrial problem that you would like to solve, then maybe we can collaborate. So we can send one of our final year research project to students. He studied the problem, and after that we can collaborate together. Because here we have
As
expertise. Yeah, we have some people are doing research in this wastewater treatment. So together we can find a solution.
can okay. I think we are always welcome if university have some researcher can maybe give us a better solution. For us, I think the amount of research or the data that we are having is not sufficient because we are talking about profit to running any company. We are not really a non-profit type of organization. So anything for us, I think we will not look into too detailed. So I think your offer is welcome. Yes,
Yes,
your
thank you.
offer is welcome.
Thank you very much.
In your process, may I ask that in your process, do you use any kind of absorption technique, sorption technique, or for?
What's the unit operation? Absorption. There is. We have a carbon filter.
Okay. So yeah, so that carbon, do you specify that carbon, I mean, the properties or the activated carbon, I believe. So do you specify the requirements for your use, the activated carbon?
Here we are using this palm kernel activated carbon. Some places they are using coconut, but because of coconut, I think the amount of absorption may not be that high. That's why we are selecting palm kernel. Another reason might be maybe the cost issue because coconut activated carbon is more expensive. So here at Johor area, Sultan of Johor is actually enforcing all the new industry need to comply to standard A. So you can see we consume a lot of activated carbon, and a lot of time we've been wondering how to regen the carbon, but in small quantity is not reasonable. So we do put in activated carbon.
I see. Have you ever tried out a polymer adsorbent instead of carbon? Carbon is very good, but polymer adsorbent, have you ever considered that?
What is the full name for carbon absorption, polymer absorption?
In any kind of polymer adsorption, like polymer beads or hydrogel type of things, have you used it or thought about it?
What is the COD remover or pollutant remover if you use this polymer absorption?
The polymer, it will be good. I mean, usually it is used for cation, I mean, chemical ion removal, actually, metal ions, for metal ion removal thing. And the range depends on different type of material used for that polymerization, for polymer process. But the good thing is it is easier to regenerate or to revive the thing, reusable. That is the good thing about it.
It is not something known as ion exchange resin, right? It is not. You are not referring to that. Maybe you can send us more information. Maybe we can select some industry. Let's try this this polymer application. I think it's okay. What happened over my side at Johor? We actually help tens of I think we have about 12 to 13 contract customer. They actually how to say, let us operate their wastewater treatment. Our duty chemical and application, they do allow us to do some trials. So if you have certain new stuff and you want to try at water treatment plant, I think you can send us the, what we call, the sample. Maybe we can try it here.
But
here
for your
we cover...
Yeah, for your industrial level, how much actually you need to do one run or testing like that? Usually how much? I mean, if I want to send you the sample, how much would it be?
I think for jar test is not representative because jar test is actually in small scale.
Yeah, it's
say we run 1 to 2 hours at the water treatment plant. We try to select a small system. What is the industry you think that your polymer will work? I mean, your polymer absorption, what's the industry you think is best suited?
For wastewater as well, it can be. It has, I mean, it has many usage as an adsorbent. So wastewater is one of the scope that it can help for removing.
It able to help to remove COD, heavy metal. What is the target of this polymer?
Target means how much they can absorb, is it?
Meaning that what is the pollutant it can remove?
Mostly the carcinogenic heavy metal.
High heavy metal. Yeah,
and it can be customized. It can be customized to absorb different materials. I mean, different things like chemical, COD for COD, like a different certain type of chemical to remove. It can be customized in that way too. Yeah, for activated carbon, it is I mean, it is suitable for everything. It absorbs everything. But this polymer can be customized that it is only for metals, only for cations, only for anions, only for like some hormones or chemical compounds. Yeah, it can be customized in that way.
I think it's good. Maybe you can send us some of this sample.
Okay.
Then we can try it on actual plant. Say your target is on heavy metal. I think we can go for some electronic plant.
All right. Okay.
And we can try some batch. I don't know, maybe few hours of application of this polymer and see whether we can produce any result.
All right.
And maybe just now you mentioned about you want to send us some researcher to help us to find some solution. In fact, we here at industry, we facing this problem like we need dedicated people to do certain study for maybe a longer period of time to get a more solid or concrete result. For us, I think a lot of time we're looking more on profit rather than put a longer time to actually.
That is what academics do actually. We do for a long time. Yeah.
All right.
I think Mr. Lim, you have another topic to share with us, right?
Yep.
Okay.
So this one will be a short one. Okay. I think I'm not really well prepared, so next time I'll make sure it's a better one.
Actually, all right, it's very important.
This is just nice. This is, I mean, just nice for us. It's quite informative and we learn a lot from it.
So now we go for another topic. This one is about how industrial wastewater is actually being operated. So as you all mentioned, I'm coming from, my company name is Eco Solution Services. A lot of people will ask me, your company is eco, meaning that you are eco-friendly and this sort of thing. So that's not really the case. The reason is when I work in this industrial wastewater and water treatment, I realized that we can only produce result if you have engineering background, you know how the chemical is actually applied, and you have the expertise to operate the system, then only you can produce the result. So at the end, the company is known as ECO, is representing engineering, chemical, and operation, because a lot of people think that if they invest in a turnkey project, they put in a lot of money to set up a system, so the system will work by itself. A lot of time, which is not the case lah. So you need chemical know-how, the application, all this jar test, and selecting the right chemical for it to move. And by the way, since we are putting operator and competent person at industry, so we actually know that without the right person to operate the wastewater treatment plant, the water treatment plant cannot actually work. So you need these three to work hand in hand, only if they can give you the result. So that's the reason why the company was known as Eco Solution. Okay, so this topic, we want to talk about how a wastewater plant is actually designed in a very simple manner. So any wastewater treatment plant at Malaysia, when you want to design the wastewater treatment plant, you must go for this 30 parameter. You need to check 30 parameter. I think students must have known that you have BOD, you have COD, a lot of heavy metal, and all this polluted. So Malaysia, we have standard A and we have standard B. So why there's standard A and standard B, I think allow me if I make a mistake. So standard A is because there's a water intake. So you have to make sure the water is very good, so that the water intake for any process, it won't, how to say, it won't give a lot of impact. So standard A is actually much more stringent. When standard B is actually near the seashore, your water is, there's no more water intake for certain application. So there's certain standard A and standard B. So here at Eco Solution, we are located at Johor, and just like I mentioned about the Johor government, and they have this issue of pollution. That's why the government giving all the Johorian that you are only allowed to have a standard A wastewater treatment system if you want to build a water treatment system. So there's no more standard B at Johor beside old factory. So for all the new water treatment, you need to comply to standard A. So so let's look at how are we going to go about when you want to select industry. How are you going to plan ahead to design a water treatment? So a lot of time, when you want to build a wastewater treatment, you must understand what is their water characteristic study. So we will conduct a 3-day wastewater characteristic study at site. So we will collect 8 hours sample. Every hour we take a sample and make a composite of it. So if you look at it here, we have day number 1, and we have day number 2, and we have day number 3. So 3 days, you collect every hour, you put into one container to make one mixture of a composite, and then you send for laboratory within 24 hours to make sure this pollutant was not actually degraded. Day number one, day number 2, and day number 3. So after that, what you need to do is actually study what is the parameter which is not complying. So this sample is actually taken for chicken farm. They are this broiler egg chicken farm. They have about 1 to 2 million. They produce about 1.something million egg per day. Most of the egg sending to Singapore. So sometimes they have this problem of they broken some egg, and when they are classifying the egg, some of the egg is actually broken. So they need to clean the egg, removing some of the chicken dung. So they have this wastewater, but the wastewater amount is actually not much. We are talking about 10 to 20 meter cube per day. But when you design it, you have to make sure what sort of process you are going to select and this sort of thing. So firstly, if you look at this industrial effluent's characteristic, you realize that none of the heavy metal is there. So there's no heavy metal there. So what we need to focus is actually on COD and BOD. COD and BOD. So there's some oil, and we believe this oil was not coming from egg or chicken dung. Is actually coming from the machine which classify the system. So this oil, I would say, is more on machinery oil. It's not actually the oil or the fat coming from this egg itself. So look at another issue here is the BOD and COD ratio is actually quite close to each other. We are not looking at 1 to 10 or 1 to 20. If the ratio between COD and BOD is big, meaning that it very hard to decompose, meaning that you need to have maybe anaerobic system and some more activated carbon to remove the COD, because it's not biological. It cannot be composed by biologically. So if you look at this wastewater sample, you will realize that these two is very near to each other. So it's about 1.7, 1.6. So this indicating the biological process will work for this wastewater. Okay. So this is some of the characteristic we are getting. So they are producing 30 meter cube of wastewater per day, and the flow rate is about 3.78, because the machine which classify the egg into grade A, B, C, D, E, F, they are only operating at 8 hours. So this is the time whereby we collect all the wastewater coming from the process. Okay, so just now we talked about the waste itself is fully biodegradable, because the COD and BOD ratio is very near to each other. So that's why this process of the water treatment plant, we are not using any chemical at all. We are not designing the water treatment plant using chemical to remove COD and BOD. We're fully using some mechanical plus the activated sludge to remove the COD and BOD. So here we are looking at a mechanical filter, some ANOX system, MBBR system, sequence batch reactor plus carbon, because you need to comply to standard A. Okay, for static mixer, just now I talked about this wastewater is actually is for this egg processing. So you have eggshell, you have some chicken dung coming out from the chicken farm. So you need we are proposing a static mixer. Basically, is to remove eggshell, some chicken dung away, so that all this solid will not clog up our palm and the rest of the machinery system. Okay, next is it will go into this MBBR system. MBBR is actually a biohousing. Some people call it a moving bed bioreactor. Some people call it IFAS. And we are using sequence batch reactor to actually reduce the COD and BOD. For information, you're using moving weight bioreactor, you can reduce the aeration size by 30 to 40%. And we have the experience that if you putting MBBL and every wastewater treatment system, when you have seasonal like Hari Raya, you have Chinese New Year, whereby there's no worker, the plant is actually shut down for few days. The system is actually failing because bacteria do not have food, so you will have upset. But if you introduce MBBL into the aeration system, it can help to actually lower the fluctuation, and the response to this, it can recover very fast. This is why I think we introduced this biohousing into our aeration system. So in fact, this is actually activated sludge. So as you can see, I doesn't know why the video is not moving. Actually, this is the video whereby you can see some, how to say, this is obviously some microorganism. This is womb. So the free swimming bacteria is here. Okay, I think students know that the activated sludge is acting as the housing for all these microorganisms to actually live in the wastewater. That's why you look at it here. We have this activated sludge, which have about 30%. If you look at SP30, we have 40% of the activated sludge. So when you put this activated sludge into microscope, and you will start to see all this microorganism activity, and that's it for that. So just now, if you look at the picture, you will realize that the settling and the water appearance is quite clear. So when you operate the wastewater plant, you have to make sure you have good settling. So good settling, you need a certain population of the bacteria. So this is the time whereby you go to study what sort of bacteria inside the activated sludge. If you have a lot of womb type, meaning that the activated sludge is at OH, a lot of time you will have a failure when the time comes. So it's about time for you to do this dewatering and that sort of activity. So you can count, and because this is actually a video, it don't want to move, I think, because I transfer into iPad, I think it don't want to move. That's actually, there's a lot of bacteria supposedly is moving around, so that you will know that there's a lot of activity inside. So another one will be, just now I'll talk about pollutant. So the pollutant actually will send to filter press. You press it, then it becomes cake. Yeah. So because this one, there's no chemical is added into our wastewater, and it's fully biological. So this one, you can dump it as normal dump site, and the government won't give you problem. If you adding some coagulant, especially metal base, aluminum base, or ferric base, this is the time whereby the DOE, the Department of Environmental, will ask us to send this slusher from wastewater plant to scheduled waste contractor. You need to pay money for the scheduled waste. Here we are talking about every kilogram of slush sending to scheduled waste contractor at 1 to 2 ringgit per kg. So if any wastewater treatment, they are producing few hundred kilogram of sludge, then is quite a high operating cost for them. So a lot of customers, if they can go for fully bio, and if they can avoid scheduled waste, they will avoid. That's why this system is actually designed full biological. to actually cater all this issue. I think that's all for this eggshell wastewater design. Is there any question?
Once again, I muted and I was talking to myself. Okay, so I was asking that this sludge that was produced from here, can it, you do it landfilling, is it? Or can it be used as organic fertilizer?
It depends on the amount of sludge produced, the quantity. I think it could be used as fertilizer. It's just the amount of this plant, because if you look at it, one day is 30 meter cube, and the just now we have this data. The suspended solid was not that high.
I see.
It's 500, so 1 meter cube is about half a kilogram per meter cube. So 30, about 15 kilogram of sludge per day. So that's not much. If you compare to palm oil mill, they are producing 10, 20 tons of this sludge. I think that is feasible. For this case, I think it's not feasible.
So this is from the chicken farm, and considering considering the chicken farm, this sludge production is considerably low, isn't it?
Yes, it's low.
So all other
this
farms,
is chicken dung. This is not chicken dung. Chicken dung, they have other process to process the chicken dung. This is the eggshell wastewater, because you need water to clean out the egg.
I see. I see. So the production of sludge from different farms are different, isn't it?
What about this one? Is for egg processing, because they have 1 to 2 million eggs, so they need to remove the dung from the chicken shell. So when they removing the dung, attaching on the eggshell, some of the egg might just broke. It breaks, so then the egg yolk come out. So they producing wastewater because of this situation. So this is one of the example, because I think biological have the advantage of because it's fully bio. That's why we go for this option.
I see. That's interesting. Actually, our students, they are exposed to the wastewater treatment in their third year. So those who are third year and above, higher, they will, this I think will be very familiar to them. Okay, but those who haven't studied, maybe a little bit, I mean, they haven't studied yet this thing. So I would like to take this opportunity to ask you that, is there any opportunity by your company for internship for our students, or for if they want to work under, I mean, in your company, interested to work, are there any opportunities for them?
There is some. I think for intern we are open, but each time we are looking at 1 to 2 students. We cannot absorb too much of students coming into the company. 1 or 2 students, I think you are welcome. But more than that, I think the seat available is only 2%.
I see. So they will go through the HR, isn't it? I mean, they send their credential and then they will wait for the reply.
You send us your CV, then we will consider.
I see.
Them
Okay.
to send the CV.
Yeah, yeah. Sure, sure.
So there's quite a number of environmental students, or how to say, who major in environment and chemical engineer in the
Yeah.
company. We have few students, which is not really student. After they graduate, they join us. They are chemical engineer. Their environment. They are working on this government application, because government application involve documentation, involve calculation, and involve the design and this sort of thing. And I am chemical engineer, whereas the other partner of mine, he is a mechanical engineer.
I
So
see.
he will do a lot of mechanical stuff. So I would say on my part, I deal more on chemical application.
Okay. All right. All right. So, anyone has any question? Any other things to know?
I think maybe Mr. Lim can share with us the job scope as a mechanical engineer in this field and as a chemical engineer in this wastewater treatment.
Okay. Me myself is chemical engineer. After I graduate, I actually further my study into environmental management. So I have some credit on energy audit and some environmental air pollution and that sort of thing. So after I graduate, I actually joined the water treatment company. So as a chemical engineer, we are good at unit processing and how it's actually operate. So when I joined this company, they will ask us to make sure each unit of operation is running at optimum. So by running at optimum, meaning that you can use chemical, you can use some of the parameter like temperature and other parameter to ensure this process is running well. I take an example for wastewater. We have this physical chemical treatment, whereby we are talking about dosage of each chemical, for example, coagulant, flocculant, and after that you will go to clarifier or settling system. Settling system, this is the area whereby we need to apply our chemical engineering knowledge about surface loading, some retention, whether it's undersized and that sort of thing. So when I joined the water treatment company, I was actually helping customer to to make sure the wastewater treatment system is actually operate at optimum. But in terms of design of piping and some of the mechanical stuff like boiler and this sort of thing, I think I was a bit behind, because chemical engineering obviously and mechanical engineer, there is some different. So to ensure that the water treatment plant can be built, can be designed, I actually opted some friend to join us and to start this design. So my partner, he is a mechanical engineer with steam cert. So he actually operate boiler for quite a while. That's why he understands how important the water treatment is. So when we join together, we able to design some system based on certain parameter. Let me take some example. If you have a boiler which running at 40 bar, your operating TDS or conductivity cannot more than 1,200 ppm. So this is one of the chemistry you need to worry. If you have too high of conductivity, you will have some carryover into the turbine, and you will have turbines skilling or attack. Then later on, your turbine will have failure and it cannot operate anymore. So for environmental engineer who join us, we actually ask them to do some paperwork to how to say, to actually go to actually test for some of the water chemistry, because for our company we have a small water lab to help customer to measure the COD, VOD. I think nowadays government actually enforcing this competent person, and the idea of competent person is to want to have uh, a certification of a competent person which able to understand how the wastewater actually work. So this wastewater person, they will know how to test certain parameter like COD and pH, suspended solid, how was actually it was being tested. So to make sure each factory can comply to the standard that DOE given to each industry. Whereas for us as a consultant, we not just taken the water sample to help each factory to test the pollutant. We also will give them some recommendation if you have certain thing went wrong. For instance, you have a wrong holiday break, Hari Raya break, Chinese New Year. This is whereby there's no process in the factory. And for another example, just now we mentioned about you have activated sludge. Activated sludge is a living organism. It starts to consume food every day. Say you have few days, there's no food for them to eat, and this bacteria start to have problem. And that's whereby time we come into picture and advise customer to have this how to say, to feed in some sugar as a temporary solution. And I also have customer recently, they've been caught by DOE because they cannot comply to the standard. This is whereby we come to their factory and study to draw the process flow of the wastewater treatment plant to ensure that which part is not complying to the standard and result in the incompliance of water. So propose them certain equipment, and we also help them to deal with government. The government part is actually consuming us about 3 engineers to handle the government case. We have about 100 customers here at Johor. You need about 3 engineers to handle, because when you was being caught by DOE, the Department of Environmental, you need to get the system back to normal in a very fast manner, because there's no more hanky-panky job. The DOE will just shut your production in when there's a complaint or they found out that you cannot comply. They will close your production and you must give them a solution. What are you going to do? And in a very short manner, because factory, they might have 100 people, workers or operator. All of them depends on this factory to find their living. So if you was being shut down by DOE, the time that you are needed to send them a proposal is a matter of 2 to 3 days to give them a solid proposal, and we need to accompany our customer or this factory to go to DOE and give them a proposal and the solution to solve their wastewater in a committed period of time. So a lot of time is very challenging. A lot of time I feel that we receive phone call even at midnight because of certain equipment failure and this sort of thing. So I would say water treatment is not an easy job. It's not like an office job whereby you will have easy money. And wastewater engineer is actually fairly challenging in the sense that you have a lot of pressure coming from production side, and you have a lot of pressure coming from government side. You need to comply, and you also having a lot of pressure that customer or factory, they prioritize production rather than waste. They will think that spending money at wastewater is the last priority rather than their first priority. Customer always view production or their product making money. Wastewater is to comply to government standard. That's why a lot of time the budget allocated at wastewater plant is very, very minimum. There's no extra of budget. And when problem come or any failure happen at wastewater plant, there's not much resources we can use. So a lot of time, I think we are actually struggle to actually ask for more budget to operate the wastewater plant in a more proper manner. So, but recently, I think especially for this past 5 to 6 years, after a strong regulation, I think 2009 regulation, I beg your pardon, it's about 11 years ago. There's a regulation in 2009 mentioned that the prosecution of wastewater treatment, only director will be prosecuted. Because in the past, when you were found guilty and you was found discharging wastewater into water source, the factory manager or the engineer will be the person to go to the court to answer the judge question, why are you not complying and this sort of thing. So me myself actually been sent to this mahkamah to sit there and listen to judge to answer, help my customer to answer those questions, why you are not complying. But after the new regulation was actually implemented, only the director will hold the responsibility. I think it helped the industry to improve water treatment a lot. So this is the time whereby a lot of factory owner, they start to spend a lot of money into wastewater and make sure they are actually complying to standard. So what else? Okay. I think can students see how your water treatment career will be?
Thank you, Mr. Lee. Any more questions from students?
I think the student already has a good insight about their career path and what it takes, what it will take them to become a water scientist, water engineer, and it was quite helpful actually. But at the end, don't become scared. Every job has some risk, you know. You have to take risk at the end. So yeah, thank you very much for your presentation. It was really nice and informative. Student also had first-hand experience that, I mean, they always get the information from the books, but yeah, from the someone who has experience, who is currently working on it, is quite new thing. So yeah, thank you very much for
that. Water treatment is dirty, smelly, and it was not like very, how to say, it's very challenging. It's very challenging, and that's not a job. It's very comfortable, but I can tell you, it's very meaningful when you see how people is actually complying to those standards, and less pollutant is actually dumped into our environment. Yeah, that's what I would say.
Yeah, it gives back us a sense of achievement or something like that, that people are listening to you.
I have to make sure everyone have the passion so that Malaysia will be a better place to live.
Exactly. So I would ask Elaine, I think it is almost time for us for this webinar. So I would I would request Elaine to present our appreciation. We cannot meet physical way, face to face. So a token of appreciation to be presented by Elaine to our guest now.
Okay, thank you, Fazlu. Let me share my screen.
Yeah, sure.
Yeah, so thanks, Mr. Lim and also Mr. Raymond for accepted my invitation, and thanks for the wonderful sharing. Your talk has definitely inspired us. It is very informative, and we are all now have a clearer pictures of like what is wastewater treatment and the system of products that used in wastewater treatment. So we are looking forward to collaboration in the near future. So let me take this opportunity to present you a certificate of appreciation from our Dean, Faculty of Engineering, Computing and Science. So I will post this by mail to Mr. Lim, and also I will send it myself to Mr. Raymond later on. Thank you so much.
Thank you.
So, hi everyone. We would like to take a photo. Screen shot. Would you like to please turn on your camera, everyone, so that we can take our photos?
So how many are we?
There were quite many, actually. So at the end, they're leaving.
A group photo.
Yeah, a good photo. I'll try to take a screenshot. Okay, I'm taking it.
You also?
Yeah, myself is here as well. I think you can see me, but I cannot see there myself. So should we be waiting for another few seconds for others to come? I think others are coming as well. Yeah. Thank you. So just wait for another few seconds for others to join. And actually, the purpose of taking the photo is to share this on our school website as a news that we are organized, and those people has joined it here. So everything will be there. All right, now I'm taking the screenshot now. Okay, hold on, let me paste it first, make sure that I have taken.
So is students still home based, or did they actually go to university now?
It is conditional now. So some of them are back to uni already, and some are not. Some are still online. Okay, so I have taken the photo already. Thank you very much.
Thank you.
Thanks a lot for your time. Yeah.
Bye.
Everyone has nice time. Yeah.
Thank you.
Okay, so Mr. Lim and Mr. Raymond, thank you very much once again for your time. And I know you guys are very busy, but yeah, we are thankful that you have given us the time. So I hope
appreciate.
Really appreciate it. Thank you. And we hope that we will meet again soon. We'll talk about other things, and hope that we will meet face to face in soon. We expect that we meet face to face soon in our campus.
So we hope that the coronavirus will be disappearing soon. So we
hope that
the vaccine will be out soon. Yes. So okay, happy Malaysia Day, and that's all.
Yeah, you too. And you guys take
thank
care.
You. Thank you. Yep, sure. Thank you. Bye bye.
Thank you. Bye bye.
Bye.
Bazul, don't forget to stop the recording. Bazul.